Hey guys, how's it going? Wonder if everyone can hear me. All right, good. Sorry about all that. I just got back from the grocery store and yeah, got all suited up. So it is officially 1 o'clock. We're gonna get started. So what we're gonna be doing is actually running through this model right here, which is my snowboard wax iron. And just give you a look at that. This is the real snowboard wax iron that I use all the time, all winter long. Um, and it's actually super fun to model because if you look at this thing, you really don't have any flat faces on it other than the bottom, right? So it's like, where do you even start? So that's one of the questions that I get a lot when talking about surface modeling is basically like, I don't even know where to begin, right? So few of the things that I want to make sure that we hit is before the end of this. Hopefully, you have an idea of like, where do I even start. The second thing is I'm gonna make sure that you understand curvature, right? What do we mean when we're talking about different types of curvature? And the third thing is I want to make sure that everybody understands the difference between a loft, a boundary, and a filled surface. Um, so hopefully you take those away as we go through here. And it's going to be a little bit slow in the beginning, just kind of like making sure we hammer home those basics, and then we're just going to be racing through features after that, because we're going to have like a full understanding of how to move forward. Cool. So on that first note, it looks like, all right, we have video. People are chatting and saying they can see me, so hopefully you can hear me as well. But what I wanted to kind of run through really quickly is like how to even think about this thing, right? So again, the question I get a lot is like, where do I even start, right? And we talked about that one flat face. Well, I think everybody on here, if you've been using SolidWorks for a little while, you can handle modeling that flat face, right? It's just a 2D sketch, right? We can do that. So that's where you start. You start with the stuff you know, right? And then after that, I'm actually going to switch to the handle because I think I can like well define where the handle's going to be, right, in relation to everything else. So I get that handle right, and really that's not only is that like pretty easy to grasp, no pun intended, but also it's probably the most important part of the iron, right? The handle and the actual hot part are the only functional parts of the iron. The rest of it is just kind of to look good and to house the electronics, right? So the next thing that we're going to do is actually blend the handle into the base, right? So that'll be kind of this portion, and we can't really grab like dimensions for that, and like honestly, I wanted to grab some pictures, but it is super difficult to get good pictures that don't have any perspective in them using just my phone on something that's so swoopy when you have to pick up dimensions from here and here and here and here. So I decided to just take measurements and go by my eyeball with the rest of the stuff, right? So after that, we'll need a helper surface on the back side of the handle here, and then we'll create this surface right here. And after that, really the back is just like the front, right? So we create this portion and then a little helper piece, and then we fill that in. And after we have these different patches, we mirror it, knit it, turn it into a solid, and go, right? So with that, let's go ahead and get started. So inside of SolidWorks, right, this is what we're going to end up with. And I'm gonna post this model. You'll have it by the end of this session. You'll be able to download this model as well. And I'm also missing some components. I'm missing this dot and this dial. So if you guys could please model that up for me and send it back to me, that would be fantastic. All right, so I'm just going to start with a new part. And I'm using millimeters because millimeters are the best, and you can't convince me otherwise. So I'm also going to use a center rectangle here, but I'm going to do this cool little thing that you may not know about from midpoints. That'll actually give me a rectangle that is that has the straight lines going horizontal and vertical as opposed to diagonal. So this represents basically just the footprint of this thing, right? It's got to fit inside of this footprint, right? So I'm gonna go ahead and I'm trying to read all of this, all these chats in here. It's pretty funny. Okay. So the first thing I need to do is actually create this spline right here, right? And I know it's going to be a spline because there's basically no flat surface on this thing. If you really look at it, none of these edges are actually straight. They're all curved. So I might start off doing something like this, right? I need to match this. I'll go over here. And perfect, right? And then, is that a sloppy spline? Yeah, of course it is, right? Now I can create some relations on the handles, right? So I can make this one horizontal, I can make this one vertical, right? So now I know at least it's tangent-wise where it's supposed to be, right? But really, this is a terrible way to make a spline. And one of the things we can do is turn on curvature combs. So if I right-click the spline, and I turn on a curvature comb, right? This is what we end up with. It's pretty ugly, right? Even if you don't know anything about curvature combs or what they are, or what they're supposed to be, you can probably look at that and go, it's probably not supposed to be like that, right? So I'm going to give you another example here where instead I just do a 2-point spline, right? So with that, I'll just have this single span 2-point spline. And I want the shape to kind of look like this a little bit. There we go. I think it looks pretty good. So now I'll show those curvature combs and we'll bump down the scale a bit. You can play with the scale and the density. Sometimes people like to just bang that density up to 1,000 so it looks kind of solid. Really, it's not very effective if it's way down here. I usually just go somewhere in the middle. And the scale is global, so you kind of have to change it depending on what shape you have. But you can see pretty easily here, I can run into a scenario where I end up with negative curvature somewhere. I get an inflection point where I don't want it. And that's really easy to do on a regular old spline, right? And by a regular old spline, I mean the spline tool that's been around in SOLIDWORKS since the beginning, right? Now, what we're actually going to use is a style spline. So style splines were originally introduced in 2014, and they've gotten a bunch of enhancements since then. But with a style spline, what I can do is, I'm sorry, I'm going to start that one over. The style spline, I could make a bunch of these little vertices, right? I got a whole bunch of them. Show curvature combs. It's still really smooth curvature, right? And that's what we want. We want nice, smooth curvature. So the really cool thing about a style spline is none of those vertices are actually on the spline itself, right? It's actually this chain of control vertices that's controlling where the spline is. But because I'm not changing those individual points on the spline, it's this single span curve, right? And there's actually some different types. So when I initially select style spline, there's the Bezier, which has been around for a while. And more recently, we've gotten degree 3, degree 5, and degree 7. All you need to know about those higher degree ones is that if you have enough of those spans, the higher the degree, the more tightly it fits to them, right? So if you had to do a shape that was going back in on itself many times, you'd probably be better off using like a B-spline degree 7. And there's some math behind there that I don't understand. So you can ask somebody else about the math. So I'm just going to do a regular old Bezier curve. And I'll go ahead and do something like this, right? And the really cool thing about a style spline is that I don't have these like weird like handles or anything. Um, I'm basically just relating to a bunch of straight lines, right? That's what I'm putting dimensions on. So really quickly and easily, I can actually add dimensions to get me a fully defined spline that has really nice smooth curvature, right, in a short period of time. So I'm pretty much going to use a style spline for almost this entire presentation, and that's why. Now there's some other things to talk about with curvature combs. So what I wanted to do was hop over to this other part that I have called the curvature zebra. And I'm going to go ahead and just focus on the sketch. And I'll go ahead, and if you click on an entire enclosed boundary, a shaded sketch contour, you can actually add curvature combs to the entire thing. And getting rid of them and then putting them back in is the only way to get this scale tool to show up. So I wanted to talk about the different types of curvature in case you're not aware. I'm sorry, like the chat window is like so small over here and I really have to like zoom in to like read it. Nice use of curvature combs. Thanks, Toby. Please make an epicycloidal curve. I'll try my best, Mr. Creator. I don't know what that is, but if I hit one, please do tell me. All right, so this is C0 continuity, or something that we call contact continuity. So contact continuity is basically two edges or two lines meet, and they happen to be coincident with one another, but that's it, right? So what we'll see here with the curvature combs is they actually won't be parallel to one another, right? There'll be like a gap there. So the curvature combs are not parallel. Therefore, we have C0 continuity. Now over here, we have C1 continuity or tangency, right? So when you add a tangent sketch relation, what you're actually getting is C1 continuity. Now, you'll notice here that where they meet, they are parallel to one another, but there's an instantaneous change in the value of the curvature. And curvature is really just an inverse of radius. So like the larger the curvature, the smaller the radius. Smaller the radius, the larger the curvature. So all of these curvature combs are a graphical representation of the radius underneath, okay? So you see there's a jump in curvature. And why does that matter? If you were doing a low gloss plastic with maybe like a texture on it, it probably wouldn't matter. You wouldn't see it, right? Or if this is the inside and you're trying to mill out a pocket, who cares? Yeah, do a tangent. It makes it super simple for the guy doing the machining, right? You can just do a ball end mill bit and or not, yeah, and put it in there, no problem, right? But we might need something like C2 continuity, right? So this is curvature continuous. Now, C2 continuity is another sketch relation that you can actually add. Equal curvature, curvature continuous sketch relation, right? And you'll notice it also needs to be tangent in order for that to exist. Now, what's happening here is the level of the curvature matches where these two splines meet up, or one's an arc and one's a spline, doesn't matter. Where these two entities meet up, they do match. They're the same value where they match. However, you can see that transition, right, is a little bit different, right? There's a ramp up, and then there's a steady ramp on the other side. So, oh, I did, Andrew Gross. Thank you for reminding me. I changed my curvature combs to match my sweater. I meant to change this back. So here's how you change the color for these things. I go into colors inside of system options, and you got to go to temporary graphics shaded. And normally the color is pale yellow. And now, can you see the curvature combs? I can't, right? Like it's ridiculously hard. So I use like pretty much vanilla SolidWorks all the time. There's just a couple things that I change. I always add a normal to button in the heads up toolbar, and I always change the color of temporary graphics shaded to purple. And the reason that I change it to purple is twofold. The first reason is that it shows up really well against the standard background. And the second reason is purple's mad nice. It's been scientifically proven. Okay? All right, moving on. So over here, just recently, we've actually gained the G3 continuity, right? And you go like, why is one C and one's G? And smarter people than me can answer that. It's for geometric relation as opposed to a curvature relation. But effectively, we can just think of it as the next level above C2. And you'll notice here, it not only matches right where it meets, but it also matches the range or the rate of change, right? The acceleration of the curvature is what it's sometimes referred to as. So this is what industrial designers and stuff are usually shooting for. Now, we've actually always been able to achieve this in SolidWorks. All right. So I just achieved it by turning on my curvature combs and then tweaking the spline as such. All right. So really, the best case scenario is we achieve the curvature that we want with the least amount of controls tweaked possible, right? Because the more ways that we bound the curve, the more difficult it's going to be to have everything match up to it, right? So ideally, we use a curvature relation to get G3, or we use a tangent relation to get C2. And we're going to kind of hit that multiple times as we go through this. So now, here, I'm going to change this back just so we can see the difference. Now I'm actually going to extrude this. And when I extrude it, I still have my edges off, and I'll hide my sketch for now. And then I'm going to go up to evaluate, and I'm going to turn on zebra stripes. Now, zebra stripes are kind of a mystery to a lot of people, so I want to make sure we covered this. The point of zebra stripes is not necessarily to see the curvature that's happening on a face, but it's really there to see the curvature that's happening between two faces. You can get some insight into seeing what's happening in the middle of a face, but really it's there to see what happens between two faces, right? So right here, you can see that these zebra stripes do not match one another. And I'm going to turn it off and turn it back on really quick, just to point out that another thing that you can do is you can bump up the stripe accuracy and just crank it all the way to the right. I do that a lot of the time. However, it does hit your graphics card kind of hard. So if your computer's chugging, you should probably turn it back down. But you'll notice the zebra stripes don't even match up here in C0. Now in C2, they do match up, but you can clearly see where that edge is, right? So if you were doing like a high gloss plastic, like this, for instance, is pretty high gloss. If I had a tangency relation right there, you'd be able to see it. There would be a seam line going down the middle of it. So typically we don't want that. Now, if I go over to C2 over here, you can see where the curvature is changing, right? You can see that little ripple there, but you can't really see where the face is, where the edges meet. And this is good enough most of the time. But G3, I mean, you can't see any change there at all, right? It's as if they're both the same face. So now, hopefully, you know a little bit more about zebra stripes and about curvature combs. Just want to make sure we don't have any more questions about that. Cool. All right, moving on. How are we doing on time? We're doing terrible on time. All right, we'll do better maybe in the future. Probably not. That's okay. So back to my part here. Edit this sketch. I'm gonna change these curvature combs so that my scales, remember the scale is global, so because I bumped it up over in that other sketch, it got bumped up over here. Now, what I actually need to do here is create this spline that's coming out and then dipping back, right? It's coming out and dipping back in. So I could try to achieve that with just one spline, but I think it's actually better to achieve it with two splines. So I'm gonna put a spline right there, and then another spline right here. But now, if I turn on my curvature combs, you'll see that they don't actually match up, right? Because I've just dropped them next to each other. They just happen to be coincident, right? So what I'll do instead is click on that vertex, add a G3 curvature G3 curvature constraint, right? And then I'll make this vertical, and then I'll be really, really nice to it, and then it'll do what I want it to do. Just be very careful. Oh, this isn't. We're still good. Okay, there we go. Close enough, I think. I'm just gonna keep trying it until it breaks. There we go. And we're gonna go ahead and call that good. And I just need a vertical constraint here, and then this is gonna be 10. Is that right? I think it's actually 5. Yeah, it's 5. Beautiful. Perfect. All right, so now I'll exit out of that. Okay, so now we got that curve right there. And the reason I said like I'm gonna be really careful is because once you start adding on the G3 continuity, you get much less leeway to where you can move those splines and have it still be all those curvature controls on the splines and have it still be within the boundaries of the maths, right? You can very easily bump it into something that's unsolvable. So you'll notice that both of this spline I'm going to leave under constrained, right? Underdefined. And if you were in my essentials class, I would go never, ever, ever, ever leave a sketch underdefined, right? And then when we get to the surfacing class, I go, well, maybe sometimes it's okay to leave it underdefined. I think usually my course of action is to leave a lot of these like weird splines underdefined until I get my finished product, right? And then you can go back and add all the dimensions and fully define everything once you're sure that's what you're going with, because you want the ability to go back in and tweak things just a little bit. Okay, cool. So now we're gonna mirror this, and I will just select stuff I want to mirror it about that. Boom. Okay, cool. So, and the other thing I got to do is turn the curvature off of this. IT is telling me that my computer needs to be restarted for updates. All right. And I'm also going to make this box construction geometry so that I extrude the right thing. Cool. So now I could do an extrude boss right now, but I'm going to start with an extrude surface because I know that the rest of my model is going to be surfacing, right? So I'm going to do extrude surface, all right? And this is on the surfacing tab, by the way. If you've never opened it up, right click, tabs, turn on surfacing, okay? It looks slightly different if it was in a previous version. Go to extrude this, and I'm going to go down with it. Now this isn't actually part of my model. What this is going to be construction geometry. Basically, I'm creating construction geometry to control the rest of these surfaces, because I know that the way this thing's made is it's injection molded with the green part, right? And then the black part actually gets pushed in from the bottom and screwed in right there. There's a screw right there, which I think is pretty clever, honestly. So this whole piece can come up through, and it doesn't need anything special. But I know that this is the pull direction, and I'm assuming that there's probably at least 2 degrees of draft on this thing. So that's what I'm going to do. I'm going to give this thing 2 degrees of draft so that I ensure that this entire thing all the way around has 2 degrees of draft on it. So one of the tricks that I always use when doing this, because 2 degrees of draft is kind of hard to eyeball, is I'll actually put on like 20 degrees of draft. Right now, I'm sure it's going in the right direction. Right, I could obviously I could flip it around. Right, draft outward, draft inward. But I'm gonna go 2 degrees and hit OK, and there we go. Cool. So the next thing that I'm gonna do, you didn't see any of that because I was on the wrong screen. Sorry about that, guys. I'm gonna go back. All right, so what I normally do is in draft, put in something like 20 degrees so that I can see it, all right? And then I'll flip it back. I'll flip it back and forth, make sure that I'm going in the right direction, and then I'll go to like 2 degrees. And there we go. And you notice that was also purple. One of the issues if you change temporary graphics shaded, it's actually the color that's all of your previews, your fillet preview, your boss extrude preview, your previews for everything changes to that color. So the advantage is now everything's purple, which is good. Okay. Why draft for injection molding? Because I believe that this was injection molded. So that's what I'm gonna draft for. I think the part was designed for injection molding. I'm sure of it. I mean, it wasn't 3D printed. I don't. I. I think the plastic's too thick to do like a thermoform this shape. So I think it was injection molded. Maybe I'm wrong though. You know, put it in there. If somebody knows any different, please tell me. Cool. All right. So now we're gonna create the sketch for this handle. So I'm gonna do the same thing as before, where I'm gonna create kind of a bounding box of where this is gonna be. So I measured to the top here is 82.5 millimeters. I measured that super accurately. Um, I hope. It's 82.5. And then I'm gonna add in some geometry for like where the rest of the handle is. Do something like this. I just screwed up. Make this one vertical. And I know that this is going to be 10. And basically what I'm doing here is I'm going to put a spline in right here that's going to be this line right here. Okay? That's the line that I'm trying to draw, this one where the green and the black meet. So put in another dimension here of 50, and then this one is 30. And yeah, I mean, I forgot to mention, here, I got somewhere around here. There we go. Got my calipers. Yeah, so this is 20 millimeters thick right there. And at the point where I want it here, it's going to be 29. Okay, and back here, it's the same width, 29. So that's what I'm trying to hit, right? So the height of it is 20 throughout. So what I'm actually going to do is make sure that the top point of my spline here is at 10 below, which is going to be half of it, right? So kind of do something like this. And now I want the point of the spline to be here. Now, if I was using a regular spline, I could just put the point of the spline coincident to that line, but I can't do that because none of these points actually touch the curve, right? So what I can do is actually put a point on there, relate my point to a line, say this line is tangent to this, and then say that this line is collinear to that. So now I've ensured that the top point of the spline is going to be exactly 10 millimeters away from the top here, right? So do that one more time. I wonder if I even need the point, I just realized. I've always put it there. So you put that point there, go tangent, and then I can say that this is, oh, I don't even need to make a coincident. I can say that this is collinear to this. Boom. Yeah, so I don't know why I'm adding that reference point. I've always done it. All right. So I have measured, and this point is, I think, 60. Yeah, 60 millimeters up here. And this point is 65 millimeters up here. Then I'll play around with the spline a little bit. Sometimes things like don't rotate the way you want them to, and you grab the entire length, the entire vertex, or the entire line here, rather than just the point, and you're able to move it the way that you want to, which is nice. So I've determined through scientific analysis that the angle right here is 45 degrees. Now you guys are probably like, how did you figure that out? I have a ferro arm in my house. No, I'm just kidding. I eyeballed it. I used my eyeballs. And I think it's pretty good. Pretty good. So that's kind of the shape I was hoping for. So I'm okay with that. Again, I'm going to leave it underdefined. We're going to get there. Okay, cool. All right, I'm just checking here. So the community objective, you guys are having great conversations in there. Love it. Okay, cool. I don't think any of them necessarily pertain to questions for me right now, which I don't know, hopefully is a good thing. We'll see. All right, so I'm going to exit out of here. Right now, I could just put a plane at the end of this point and sweep the shape across. Now, that sweep shape that I'm going to use is an ellipse. However, if you look at this handle, it actually gets wider, right? Like it's wider right here than it is right here or back here, right? So I need that thing to get wider as it goes, but it's the same height, right? It's the same height the whole way through. So what I'm actually going to do is use another trick called a projected curve. And it's one of my favorite tools, and we're going to use it a whole bunch. And basically, if you're doing surface modeling without a projected curve, you're going to have a bad time. So we'll do something like this. And we'll make these collinear. And then I want to make sure that this curve, which is what it's going to look like from the top, matches up perfectly with the other curve in this direction, right? So basically, I just need a vertical relation between that point and that point, but I can't click on that point, right? And that's because SOLIDWORKS doesn't allow you to select a point that's on a plane perpendicular or normal to the plane that you're looking at, which is a good thing, because if you had a sketch with 1,000 points in it, you wouldn't want SOLIDWORKS to be trying to grab all those points every time you move your mouse over it. That would be ridiculous, right? So what you got to do is just rotate the screen a tiny bit, and then you can grab that point. All right, so now I can say there's vertical here and vertical here. All right, and now I know the width of this thing as well. The width in the beginning of the end and the end is going to be 29, right? So what I'll actually do is say 29 divided by 2. Boom. I've already made them collinear. This I could have gone and measured this more accurately, but I'm just going with looks here. I think that looks pretty good. Maybe move this one back just a little bit. Cool. So I'm happy with that. So now, basically what I want is I want a curve where if I were to extrude this surface and then extrude this surface, I want a curve where those two faces intersect with one another. And there's actually a tool that you can use for that. So I can go into my sketch toolbar, and you may have never noticed this, but there's a drop down underneath Convert Entities. And in that drop down is this tool called Intersection Curve, right? So if I click on Intersection Curve, it basically gives me a whole bunch, just grab whatever you want, and wherever it intersects, we'll make a curve, right? So grab this face, click OK, and all of a sudden, we have a curve that matches exactly where those two faces intersect with one another. And you can see this is this wacky 3D curve that would have been extremely hard to create otherwise. But because I know what it looks like from this angle and from this angle, it's actually really easy to generate. But there's this other tool where you don't even need to use the intersection curve of the 3D sketch. Inside of the surfacing toolbar is curves, right? Maybe you've come up here for split line. You can also go into project curve. And if I go to sketch on sketch, it's essentially going to give me the exact same curve. It's as if I projected that sketch in this direction and also in this direction. It's where they would meet up, right? So that's a project curve. Cool. So now that I have that, I'm going to show this sketch again, not that sketch, but I'm going to show this sketch again. And this is something that you didn't used to be able to do until a couple years ago. You can actually reuse a sketch that's inside a projected curve. So if you're on an older version or you haven't tried this in a while and you're like, how did he do that? It's just we made the software better. So now I have a path, and now I need a profile for my sweep. So what I'm going to do, what version of SolidWorks is this? It's actually 2020 version 2020 SP01 is what I'm currently working on. I think that's all. Some people, it's their favorite tool, so that's exciting. All right, good. All right, so now I am going to go add a reference plane. All right, so one of the really cool ways you can add a reference plane is you can actually just select any entity, so line, curve, spline, whatever, and then also select a point on that, and it will be a plane that is normal to the line entity that you've selected and coincident to that point, right? So this is super useful when I'm trying to create a sweep, because usually it's for a shape like this. So now I'll go create the sketch. Now I mentioned that it was going to be an ellipse, but I'm going to be very deliberate about where I put the ellipse, okay? I'm going to start the ellipse over here and deliberately make it crooked and not touch anything, right? This is for a very good reason, right? If I try to make it coincident right there, I might accidentally make it coincident to this line, right? And then I haven't actually tied the thing down, right? And that's why whenever possible, I like to use the Pierce relation. If you guys got to see Toby's coffee cup model a couple weeks ago, if you were on for that, he used the Pierce relation there, and he did a really cool thing where he actually drew an arrow, right? And he was pointing out that the Pierce relation is for when a line pierces through a plane, right? So now, full disclosure, I could absolutely add a coincident to there and it would work, right? But one of the added advantages I have is when I do a Pierce relation by selecting the line entity and also the point, right? I can verify that they actually do intersect with one another. One thing that could happen is I could get so far down a road, right, and then all of a sudden have the sweep fail or many other features fail and go like, why isn't this working, right? And then I got to check 15 different things where it may have just been that I didn't actually have things lined up properly, and the Pierce relation would have alerted me to that immediately because it would have said you can't pierce that, won't work, right? Because they don't actually intersect. So now, remember I made it crooked on purpose? That's so I can do a Pierce relation here and visually verify that it's actually moved, it's rotated, it's gone where I want it to go, okay? And now I'll just add the dimension on the top, which is going to be 20, right? And now I have all the elements that I need. And you'll notice that it's going to stick with this 20, so it's going to stay the same height, but it's going to ride this rail. Imagine there's a little hole there, and it's riding along this rail here, so it's going to get wider as it goes, right? So we refer to that as a guide curve. I'm going to hide this plane so I can see what's going on. I'm going to go to Swept Surface, Sketch Profile, Sketch Path, and then I'll come up here and I'll select my guide curve. Right, and you see how it got wider, so it keys into that, right, and now I've got this geometry. Now, I could have absolutely done exactly the same steps, exactly the same geometry, exactly the same everything, and created a solid sweep right there. But it would have just caused me more steps in the long run, because really what I want to do is I want to take 1/4 of that ellipse and blend it down into here, right? So because I only want 1/4 of that surface, right, I'm gonna make it a surface body right off the bat. And then what I can do is start splitting it up. One thing that I'm gonna do a ton is I'm gonna come up here and just click on that eyeball to go hide all types. So that very quickly just hides all the planes, all the sketches, all the everything, right? Which we're gonna need to do a bunch. I'm gonna go into front plane and say split line, and I'm going to do an intersection, right, just like an intersection curve, right, where these two intersect with one another between this face and the front plane. And I've actually split that face into two faces. Now I'm going to do exactly the same thing, except this time I'm going to do it with this sketch. All right, so I'm going to go split line, and this time I'm going to do a projection, right? I'm going to project this sketch in both directions on these faces, and now I've split that, and now they're split into fourths, right? So now I've got this edge right here, which needs to get blended down into this edge down here, all right? So the first thing I'm going to do at this point is check and make sure that I haven't gone completely off the rails. It's a Lenovo P51. You're correct, Toby. All right. I can see the reflection in his glasses. What can you see the reflection of? Can you see this ridiculous, like, messy room that I'm in right now? I'm hoping not, because this is the only clean portion of the entire room. All right, I'm going to move on. So now, I hadn't even thought about the reflection in my glasses. I did not clean up the rest of the room. So we're going to create a sketch on the front plane here. And I'm going to use a style spline again, and I'm going to do this over and over again. I am going to deliberately not connect my endpoints until I rotate to the side and I am extremely positive about what endpoints I am connecting, right? Now, I could make this tangent right here, make that tangent, or I could make this line and this line collinear, and it's exactly the same thing, right? Because all that the tangency is doing is making sure that that first control line is lined up with whatever other control line it is. And I'll do the same thing here. Make sure that I'm selecting the proper geometry, and I'll make these tangent. And then I can play around with the shape at that point. And I think I want something kind of like this. I think I'm happy with that. So I'll go ahead and exit that sketch. So now what I really want is I want another sketch or curve that represents this portion right here, right? That's where I'm chunking it up. So to do that, I'm actually going to create another sketch on the front plane with a spline like this, and rotate to the side. I totally would have just cheated right there, but then I realized that I just told you guys my rule, and I have to stick to the rule. You know how it is. I'm going to make these parallel, and right here, I can't make this coincident. All right, I mean, I'm sorry, I can't pierce it, right? Because it doesn't actually pierce anywhere, right? Well, it does, it pierces right here. But I want it to be coincident over here somewhere. So it makes it flat on the bottom, but now what I actually need to do is define a distance over here where it's going to land. And I've determined that to be about 20 millimeters in. And we'll make this one tangent. And then really all I'm doing here is just making sure it like looks right, that the flow looks right. And I'm pretty happy with that. Cool. So now I'm setting up to do another project curve. So I've done it from that angle. Now I need to do it from another angle that's 90 degrees from it. It doesn't actually have to be 90 degrees, but usually that's what you want. So now I'm going to say, whoops, coincident there. And here, I'm kind of worried about this being proper curvature. So I'm actually going to say that that entity there and that line is curvature continuous, okay? And not just tangent. And that's actually why I added some extra geometry in here. because if you say curvature continuous, it will actually do that. So now I'm realizing I don't know what this angle is, right? Like I can't actually make that 2 degrees because it's not actually 2 degrees. It's going to be intersecting somewhere over here. And if I have something at 2 degrees, but then I rotate it to the side, right, what I'm seeing is no longer 2 degrees, right? So what I actually need to do is make sure that I am 2 degrees right where this is intersecting. So what I'll do is I'll roll back and I'll add in another reference plane that's parallel to the right plane and intersecting this point, okay? That's intersecting that point. And then I'll do another split line intersection between that plane and this face, right? And then now I actually have this edge here. And then what I'll do is I'll say edit sketch plane, right? So now this is a way that I can say, actually, I want to keep this sketch. I'm happy with it, but I want to move it to a different plane. And as long as if you're moving to a plane that's parallel, it'll always work. If you're moving to a plane that's almost parallel, it'll mostly work. If you're moving to a plane that's perpendicular, it will never work. So now I've moved it there. And now, hide this. I'll go and edit this sketch. And I'll say coincident right here. And then I'll make these 2 lines tangent. And then now if I measure this angle here, notice it's not 2, it's 2.19. So you got to be really careful when you're working with drafted parts like this. All right? You can't just assume that it's going to be 2 degrees right there. So I'll move this up, kind of get the angle that I want. I'm happy with that. And then again, this is just another projected curve. So I'll select that one and that one. And now I've got this, pretty difficult to attain project curve. So now what I actually want to do is create this surface in here, right? So what I'm going to do is this is where the question becomes like, should I use a filled surface, a lofted surface, or a boundary surface? Right? It's the other ones up here, right? We've probably all used extrude and revolve and sweep, but not a lot of us have used loft, boundary, or filled, right? So what I'll do is I'll start with a filled surface, and I'll grab that patch and that and that and that. And hey, it worked. Great. I've got something in there, right? And I'll say that it should be tangent to that face and tangent to that face, right? And we're looking pretty good, right? And I'll turn off optimize surface and it looks a little weird, right? And then you're like, well, what's going on here, right? So you can actually go down to curvature display and go to the mesh preview and we'll crank that up. The difference between optimized surface and not optimized surface is what a non-optimized surface is doing is it's actually just stretching this UV curve, almost like you can think of it like saran wrap, like stretching the saran wrap over the boundary, right? And then trimming it away. As opposed to when I click optimize surface, it's actually treating it as though it's a 4-sided boundary, right? But the problem with that is if I want to treat it like a 4-sided boundary, like filled surface doesn't give me many options, right? I don't really have a good option for a lot of these pieces here, right? So if I went back to this, it does actually. Why does it give me tangent? Yeah, I can't. Yeah, I can't apply a tangency constraint to a sketch, right? So really maybe what I want to do is I'll come in here and do an extrude surface out this way. And I'll also create a lofted surface here just as a helper surface. Okay, and we're going to go back and explain that. But now if I went and did my filled surface, and I'll unoptimize it, right? And I'll say apply to all edges and I'll say tangent. It actually looks okay, right? And then I'll go, what about curvature? That actually looks okay too. I'm actually shocked about that. But usually this will screw up. Oh, it's because I didn't optimize the surface. Yeah. But oh yeah, so optimized surface won't even work in this scenario. Really, a filled surface is not for a four-sided boundary because now I can't actually tweak that anymore. It's either on or off, right? So what I could do instead is create a lofted surface in here, and actually I'm going to go ahead and get rid of this loft and show my curves, and I'll do a loft from here to here, and guide curves, I'm going to use this edge and this edge. So notice in a surface loft, we get profiles and guide curves, right? And the curvature looks very similar to what I had before, except now I can do tangency to face, and then start and end constraints. I can do tangency to face and tangency to face, right? But I can, and then what I can do is I can actually pull these, and they're almost like spline handles, right? I can pull them to make it influence it more, right? But I can't do anything with the next guide. So I want to show you this real quick. Not that, but my loft versus boundary patch. So what we're doing here is just creating a four-sided boundary. Here's my surface loft, and I haven't done anything. I've just gone and selected them. They're not even like tangent or anything. And then here's a boundary surface. You notice that the boundary surface is not the same as the lofted surface, right? And actually, if I turn on my, cross section here, and I'll do section number 2 also from here, and we'll just look at this thin little strip. You kind of see how the green one is a straight line, where the purple one is actually this sine curve, right? And that's actually because if I untrim this, so surface untrim is this other weird tool. Don't worry about the surface untrim, but what it's doing is it's basically extending out the edges using that same curvature, right? So it's expanding out the curvature that's internal. And if I look at that, I can see that there's a straight line here, whereas there's this sine curve looking thing here, right? So the green one is the boundary surface, and that's because in a boundary surface, you don't have guide curves and profiles. You have direction 1 and direction 2, and they are treated completely equally. Direction 1 and direction 2, that could be flip-flopped, and it wouldn't even matter. It's the exact same thing. So that's why you get this straight line here, and that's why you get a different shape. And also with boundary surface, not only do I have the ability to tweak this stuff, right? So I can say these are both tangency to face, but I can also tweak the other stuff. And then I have a slider bar for how much influence I've given each piece as well, right? So a boundary surface is actually much more powerful than a lofted surface, and it was created a number of years later. So what I end up doing is I actually create what I do is I use boundary surfaces for the parts that are going to be like a part of the model, like the actual face that I'm going to see. And then my lofted surfaces are usually my construction surfaces, my helper surfaces. This one is good. I hope that's good. Says he's going back to fully defined sketches. Yeah, I'm not going back to fully define them. In fact, the file that you're going to get is not fully defined, so you can go back in there and fully define all the sketches if you want. I'm not going to do it. So what I want to do right here is create a boundary surface in here, and what I'm going to do is I want a helper surface right here, because I can't just say, like, if I just attach this to the curve, I can't say it's like tangent to anything. So what I'll actually do is just really quickly add a lofted surface right here, profile, guide curve, right? And I don't care about the rest of this surface. What I care about is how it matches up here, right? And it's going to blend this together. And now what I can do is when I add my boundary surface, I can actually relate to that face and say, this is the curvature I want you to have right there. And then I'll be able to change the other side as well. So now I'll go edge here. Now notice I'm clicking on the same side of the edge. If you click on the opposite side of the edge, you get the twist. One of the nice things about a boundary surface is you can actually right click on it and say flip connectors if you accidentally do that. But just make sure you're clicking on the same half of the line. And a tendency for people is to click on the middle of the edge. Get used to clicking near an endpoint. Because you click in the middle of the edge, you don't know if you're 51% or 49%. You can't predict which side that vertex is going to go to. So if I click on the same side, I'll always get it to the same place. Now I'll go direction 2 here. Now be careful, if I select this edge, what I actually selected was a curve, right? Because I actually have that projected curve right on this right on the face of that edge. So this is why I'll go up to hide all types. And now if I select that edge, it's actually the edge. And the difference there is when I actually have the edge selected, now I get an option like tangency to face. So I'm going to make all these tangency to face. And what I'll end up doing is going back and checking with zebra stripes. And if I need to, I can bump one up to curvature to face if I haven't maintained curvature continuity everywhere. But for now, I'm just going to make them tangency. So the next thing I want to do is this little helper piece right here. So it is the top of the hour. I'm actually like 15 minutes behind where I hoped to be. It looks like, so I want to ask you guys an option, right? So I can go to the full model, right? And then roll back and talk about how I did some stuff. Or I can actually model it all the way through. And I'm happy to sit here and model it all the way through. I've shown you the difficult parts now. The rest is just doing the features. Like I'm basically going to be repeating the same stuff over and over again with the added complexity of adding a filled surface in here. So what I'd like to do is actually I'll get to the filled surface and then I'll get to the filled surface and then I'll check the chat to see what you guys want to do. If you want me to just go to the feature tree and do the rollback bar and talk about what I did, or if you're interested in sitting on and I will model the rest of the thing through, it'll probably take another 20, 30 minutes probably. So with that, I'm going to get up to the filled surface. So I'm actually going to go and create a plane that's going to be 30 millimeters up here. And then with that plane shown, the next thing I need to do is create this curve on the inside here. And I'm going to make these curvature continuous. And then the reason I added that plane first is because I basically want this I want this opening, like I've determined 30 millimeters is approximately where it crosses over. So like that should be, it should look something like this. This is where, you know, it's basically close to vertical right there. And then this is going to be really tight curvature in here. And I think I'm okay with that. So we'll hit escape, I'll hit exit sketch. And then I will do an extrude surface out this way. That's my helper surface, right? And then I'll actually do a split line between this plane and this face. And then I will create my curve that's going to attach these. I think I might actually need another vertex in there. That's okay though. You can always add a vertex. I don't think I've shown you that either. So I will show you that. These collinear. If I click on a style spline, I can say insert control vertex. So I can always add one. And the reason I think I need to add one is because curvature continuity needs 2 of these. And this needs to get bumped in just a little bit more over here. Yeah. Okay, cool. So now I've got that. And then I'm just going to add another boundary surface here. Turn off all types so that I can grab not the curve. And we'll say tangency to face here. Nothing at the bottom. Tangency to face here. And tangency to face there. Cool. So now, let's see. I've got time. Keep going, bro. People are loving this. Thanks, Toby Schnars. Model it all the way. We have all the time you need. More than happy to watch. Go all the way. Christian Blanc says, smiley face with sunglasses. Thanks, Christian. All right, cool. So that's awesome feedback, guys. So what I'm going to do next is create this line here. So basically what I'm going to do is imagine slicing this thing down the middle. Right here, I'll make my screen a little bit bigger. Imagine slicing this thing down the middle, right? What would this line here look like? And it's really hard to tell, I'm sure, on like a webcam, but basically it's gonna kind of it has a bump on the top and then it goes down and another one on the bottom. Did you actually? I wasn't in the right part of the screen. It's gonna look like this, right? So it's kind of a weird shape, but what I'll do is I'll do split line. Intersection between this face, I don't need it here because it's actually already where it is. And now I'll create that geometry on the side there. And I want to make sure that I don't accidentally grab any the bad stuff. By bad stuff, I mean stuff I don't want to hit, like random entities that I don't want to. I want to make sure I don't accidentally create a relation to. You know how sometimes you're like, why is this sketch overdefined? And you find out you like accidentally made like a perpendicular relation some random place. So I try to just put them off in space somewhere initially. Coincident. Really, I can just make this one horizontal too, because this is horizontal, right? The flow of the thing. All right, I'll do something like this. I think looks pretty good. Just make sure I'm not. Okay. Sorry. The people helping out with the webinar on the other end told me they might call me if something went wrong, and my phone's like blowing up. Oh, you can't see my screen again. I'm terrible at this, guys. I'm sorry. So you see the spline I created. I think you get the point by now, right? I don't need to create it again. And by the way, if you're like looking at these splines and you're like, how the heck did he know to put the control vertices there in order to do this, right? Practice. Honestly, it's like just creating a bunch of shapes over and over again. One little tip is you will get an inflection point wherever one of these lines crosses over the spline. So if you know you need an inflection point somewhere, like it's going to go from positive curve to negative curve, then that's where one of them should be crossing over the spline. So I'll exit that sketch and unhide it. And I'll do the same thing here with my lofted surface. I'll go profile, profile. This is just a helper surface, right? I'll make them tangency to face, tangency to face. All right, that's just my helper surface for this 5-sided opening, right? Now, what filled surfaces are for is they're for n-sided openings where n does not equal 4. right? If you have a four-sided opening, use a boundary or a loft. Like they're much more powerful. But if you have an opening that's one-sided, like a circular opening, or two-sided, like something like that, or God forbid, three-sided, right? You can always use a filled surface for that. Now, the trick with the filled surface is you always want to have as many edges and as many constraints around it as you possibly can, because it's actually you get less definition, right? The middle is kind of you're up to the whims of wherever the curvature is going. So you kind of have to make sure you have everything bounded in pretty well. And then what I'll do is I'll just go into filled surface and I'll create a boundary and I'll start at the bottom. And this is what I always do, because especially when you have like an opening that's like, 12 sides, you really want to make sure that you know where you started and you know where you ended. So I'll always go to one that I'm keying in on, and then I'll go clockwise around, grab all the edges, right? And now it puts this filled surface in here. And you can see optimized surfaces checked, right? But it's automatically been unchecked in the background because it can't possibly fit a four-sided surface into a five-sided opening, right? So really, like, I just leave this thing unchecked all the time. So it'll save whatever you last put in. And what I'm going to do is, I'll just go apply to all edges and I'll say tangency. All right, so I think that looks pretty good. But one of the cool things you can do is you can actually turn on zebra stripes. And if you have zebra stripes turned on the model, actually, am I cranked up? Nope, didn't think so. See how they got a little tighter? If you have zebra stripes cranked up on the model, then what you can do is you can also have them on your preview, and then before you even exit it, you can go like, actually, this isn't achieving what I want it to, right? It's actually C2 continuity everywhere except this face. So I know that one is the third face down, and I can say curvature right there. Oh, I just changed them all to curvature because I have applied to all edges. Sorry. Uncheck, apply to all edges, and I'll just try and change it to that one. This doesn't work sometimes. Did it work? A little bit. This actually has like a weird ripple on the bottom of it. So you know what I want to do is, because I've identified that weird ripple, I'm going to go back to this boundary surface. And what I want to do is, oh, you know what? That's why. Because this one is not tangency to face. And now what I'll do is I'll scrunch up this tangency influence. No, that's not helping either. Maybe I need to do tangency influence on the other side. That's just accentuating it. We're doing great, guys. So that's probably something that I need to fix somewhere, but we'll leave it for now. It wasn't a problem on the other model that you guys are going to get. We'll just keep moving because I want to make sure I get through these in a reasonable time. But that's something that I have to go back and check. The way I would fix it is probably by tweaking that spline. It could be that the curvature just gets way too tight right there, and on the bottom face, it's just not able to. It doesn't give me what I want. The other option is I might be able to try and do a lofted helper surface between here and here, and then make a tangent to that, so it stretches it out in that direction. So there's a few different options that I could go with. So now what I'm going to do is actually go to the back of this thing, right? Because this is going to need to be another filled surface in here. And if that's a filled surface, I know that I need to have it bounded everywhere. I can't just willy-nilly put a sketch there and go for it, right? So I'll have to put some sketches on the back side and create this back face first. And remember, you can't make that vertical. You got to make it collinear because that's 2 degrees of draft right there. You always got to be cognizant of that. And I know that I need this. This like basically drops off like almost immediately. Something like that. And gets a little tighter up there. Yeah, I think that looks good. Call it a day. All right, and now we're same as before. We're doing this projected curve, but I know that I want this curve to go down in this particular direction, like that. This one will be vertical because I'm looking at it from this side, and then I have a dimension here, which is 25. And then I'll make this curvature continuous here. I'm trying to grab edges. I think edges sometimes are better than like curve geometry or sketch geometry as far as like updating things later on. So that's why if I have a choice between the curve and the edge, I'll grab the edge usually. And now again, reference plane. I'm sorry, I'm clicking so fast, guys. But hopefully at this point you know what I'm doing because it's really the same exact workflow as it was on the front end. Whoops, forgot to do my split line, right? And because I forgot to do my split line, I don't have anything to reference right there. So I'll roll back to between the sketch and the plane. And I'll say split line right here. And now reference this, and we'll say curvature continuous. And we want something like this shape on the back. The back looks quite a bit different than the front. Let's see what it looks like back here. All right, this like bump that comes out in the back. Get the light to hit it. So yeah, that's what I'm trying to achieve right there. So we got that. And now we've got the two curves that I need for my project curve. Right there and right there. Looking pretty good. All right, so now second verse, same as the first. And we'll do a lofted surface from here to here. And we'll select that curve and we'll say tangency to face, tangency to face, click OK. And now we'll turn off that curve and I'll put in my boundary surface right here. So I'll go from the top here, I'll get this quarter of my ellipse. And then down here, you'll notice this is actually two edges, right? So I need it to act as though it's one edge. So what I can do is right click, selection manager, click this edge on this side of it because it remembers which side of it you picked. If I picked this one, then the ball would end up down here. Click this side, now this one, and then click OK. And now it treats it as a group. Open group is what it shows up as. All right. So now I'll select this edge and this edge. And we will say tangency to face, tangency to face, tangency to face, tangency to face. Now you'll notice we've kind of got this slope right here, right? But it doesn't give me like that. It doesn't give me like a bulge where this bulges out right here, right? So I actually am not achieving the curvature that I want to right now. Also, it's got this like hard edge that's coming down through here. If we looked at just this portion of it, right about there, it's almost like a hard edge that's coming down that I don't want in there. So there's a couple things you can do. You can go right click, add connector, And then what I can do is actually realign the mesh, right? You notice it was up here originally, right? Kind of at a slant. And really what I want it is I want it to be kind of perpendicular to where my edges are. And that helps a little bit, but not much, right? But one of the big problems I have is the fact that up here, it actually wants to curve around, right? And that's what's making that hard edge right here. Like that shouldn't look like that, okay? So what I'll actually do is back out of this, and I'll go to the loft, and I don't have any time to tell you why this works, but if you change the influence type, you get a different shape, right? So next edge, next sharp, and global give you a different shape. So this guide to this guide, basically it's like halfway through the influence switches, as opposed to next sharp, which is going to be this vertex to this vertex, okay? So now what ends up happening is this switch over ends up higher, right? Which is actually what I want. So now if I did the same thing with the boundary surface, only I'm actually also going to create a secondary sketch plane in there for me to create an intermediate sketch. And this one is 40 high. And then create a split line on that face and that face. And you can see how it actually like swings out a bit, which is not what I want. So what I'll do, whoops, is try and mitigate that by having the curvature influence just be like pretty short. So now it does bulge out just a little bit, but not like it was before. Like now it's kind of flatter there. And that's actually what it is. It's like right here is very flat on the model. So now that I have that sketch, turn on my types, hide this plane, and we'll go boundary from here to here, selection manager, select on the right side, on the correct side, I should say. And then turn off my types so I don't accidentally select that curve. And we'll do selection manager again, here and here. And something weird happened. I think I selected both of them and I didn't click OK. All right, so I'll show my sketch again. Hide that. Selection manager from here to here. Selection manager from here to here. Click OK. Oh, the group still got screwed up. It's weird. Oh. How many of you were watching that happen and you were going, no, don't click there? That would have been me. I would have been like, you dummy, you're selected in the wrong box. So I was actually still in direction 1. I hadn't switched over to direction 2. Now it works exactly like it should. And now I'll go tangency to face, tangency to face, tangency to face. Another cool thing is you can actually get some intermediate controls on. You can get controls on the intermediate profile with a boundary, and you can't do that with a loft. Tangency to face, and now if I bump up the influence, there we go. Boom. There's that bump that I wanted. Click OK. And I think that looks pretty darn close. Can't figure out how this works. Right? All right, guys. Wow, it's a lot of time. I appreciate you guys sticking around. I think people are still sticking around. Okay, people think I think people are still enjoying it. It's so hard to tell. So what I'm going to do is basically I have one quick feature, one feature that's not as quick, and then I'm just mirroring it, creating a solid, and we're done. So split line, intersection between here and here, and on that same face, I'm going to create my intermediate or my sketch that's going to bound the bottom. See, I'm breaking all the rules that I created. I love doing that. And do something like this. Yeah, kind of like that. Cool, cool. And we'll create a boundary surface here. Boom, boom. This side, and then make sure I don't select the curve. This side, and we'll say tangent C, tangent C, tangent C, and none. And we'll bump up the influence on the blue one. I think it's like kicking that back off. It's weird. Yeah, I think that looks nice. Cool. So now, last feature, it's also going to be a filled surface. Well, not the last feature, but the last real like difficult one. Start on the bottom, going to go clockwise. Fill it in. We'll go apply to all edges, and we'll say tangent. And it looks kind of like I want, except right here, it really should be like, there should be this line that happens right here where there's essentially two different like slopes. There's the slope right here and the slope right here, right? And in between that slope is kind of like this, right? So one of the cool things you can do with a filled surface is you can actually add a sketch, right? Or a constraint curve essentially. So I'm going to go back before this, and what I'm going to do is create a 3D spline. Andy, don't ever create a 3D spline. I know, I say that all the time. Never create a 3D spline. Don't do that. It's a terrible idea, right? But if it's just a 2-point spline, right? If you're just going from here to here, it's just a 2-point spline. Sometimes it's okay. Now, remember, I don't know what slope this thing is at. It's not 2 degrees. It's somewhere in between. I have no idea, right? Here's a cheat code. Nobody knows about this. You need Game Genie to get it, okay? Click on the spline, hold Control, click on the edge, and then click on the face, and then you get the secret relations. You get tangency to face or equal curvature to face, right? So I'll say equal curvature to face right there. And then over here, I'm going to do the same. Select the spline, select the edge, select the face, and then I can get curvature to face, right? So now I've got this spline that defines this like flow line essentially here. All right, I can move it back and forth, and no matter where I move it along this edge, it's going to maintain that curvature continuity to that face, wherever it is on that face. So now I'll go back in. I'll go back into the fill, and I'll unhide the sketch. No, it's shown. Do I have hide all types on? Yep. And I'm just going to turn off, or no, I want to leave zebra stripes on so you can really see the difference. So sometimes you can see like coming up above. Now if I click this as a constraint curve, you see the shape actually change, right? So there's more of a dip in here and it kind of rolls up over there. All right. So now you get that secondary level. Now, if I was really crazy, I could actually go turn instant 3D on. Don't do this, Andy. This is a terrible idea. What are you thinking? Right? And then I could select a point and I can actually move that spline live, and then it actually updates the shape. Turn on our zebra stripes so you can actually see it. So if I click on that edge, or click on the spline, I move it, click off, it'll actually update that shape live, and I can start playing around with it until I get what I want. And this is also like a great way to make your computer just freeze up. So use it sparingly, okay? um, so now at this point, I could go back through and say like, there's actually some faces where really like right there, I'm seeing tangency and maybe that's not okay. Maybe I need curvature to face there. So there's probably some places where like, remember this one was kind of weird. That actually might kill my shell too. But we can try it out. So basically at this point, I would just hide this one, hide this one, hide this one, and then I only need half of this surface. So I would go up to delete face because this is all one body, and actually delete these two faces, right? And now I have half of my model. And then from there, I can use the regular old mirror command about the front plane, bodies to mirror, select all of them. So now it's got this mirrored over to the other side. Right, and then I can use planar surface, and whoops, let's go normal to it. And then what I'll do is I'll just window box the entire bottom. Quick, easy way to grab all of those edges. And then from there, knit, get everything, knit everything, create a solid. Now we're a solid body, right? And then from there, I can do my shell, which I predict will fail because of that spot right there. Ha! It worked. All right. So you can see that was super simple and really easy to do. And it only took me an hour and a half. I'm sorry about going way over time, guys. I hope that you enjoyed it. For those of you who were able to stick on, we'll have this video posted, and I am going to also give all of you this model, which also has some other cool stuff in there. Like there's how did you create this or this? There's actually a wrap feature on this. This is actually, it's hard to see, but this is the cord is actually 3D spline, and I'm using twist to twist along spline to make it look real. There's also, this is, I believe, accurately built here where I used a split line and then a ruled surface, normal to surface to make sure that I actually got the edges the way they should be. So there's some other stuff in there that you can kind of investigate. And again, I still need this light here and this dial modeled. You can look this thing up. I won't name the company, but there's the company. You can look this thing up and find it like really quickly, so you can get pictures of it. And if you guys update the model and send it back to me, I'll definitely post it and give you like a shout out. All right, let me see if I got any more questions before I get off. Let's be on the channel. Where do you recommend for going for good detailed knowledge of SolidWorks? That's a great question. Honestly, some of the best surfacing tips that I've gotten are from previous SolidWorks worlds. And those are usually posted shortly after SolidWorks World, and you can find them. But you can find a lot of those videos after the fact. And Jordan Tadich, who works for SolidWorks, has a ton of great surfacing videos. There's this guy, Andrew Lowe, who's got a ton of great surfacing videos. Obviously, you can always go to My SolidWorks. My SolidWorks has like a bunch of videos that are vetted, right? Like they're put out by our resellers. Your reseller probably has a bunch of videos. And the reason that the content there is better necessarily is because any Joe Schmo can put a video on YouTube and go like, this is the right way to do it, right? And it might be terrible modeling practices, but the stuff that you're going to find on My SolidWorks or My Reseller is going to be quality content for sure. So like the SolidWorks YouTube channel and my SolidWorks is going to be the place to go. Somebody says, Lofted Surface can pretty much do all the work instead of filled and boundary. And am I correct? Basically, any shape that you could create with a boundary, you could also create with a loft. Boundary just gives you more controls. I like it better. It's kind of like the difference between a regular spline and a style spline, where like if if you can create the exact same geometry with a regular spline, you don't need to use a style spline, right? It's a preference. You've become accustomed to that tool, and you can make it do what you want it to do. I personally believe that boundary gives me more tools to get the shape that I want. Um, there is like there's one thing a loft can't do that a boundary can do. And when you create a lofted surface, you can actually right click on the surface body and say add loft section, and it will put an intersection plane there and give you that profile wherever that is and actually add it. And it's almost akin to adding a point to a spline, where it just by adding the point, you've changed the geometry, but then you can also change where that point is. You can change where that loft profile is. Obviously, I effectively did that with my boundary surface, but I had to go back and add in the geometry that I wanted as opposed to being given this is the geometry at this point right now. So sometimes that can be pretty handy. Uh, wish to see how you can fix the front side curvature issue. Um, let's see what I did on this one. If I go to, it's, did I do? Yeah. So on this one, it's tangency, tangency, tangency all the way around. But yeah, you see this sketch? This sketch looks different than the other sketch did. I think the other sketch was tighter in here. I think that's what's happening is it's just it's 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 really tight in there. And I've also that's what I attempted to do was change the tangency influence to kind of say that this profile is more important than this one and this one. So rather than stretching it equally, it's stretching it more in one direction. So that's going to be the fix is to go back in and change that sketch. But I'll be honest with you, like I don't really desire to do it live right now because by changing that sketch, it may cause some other downstream things to fail, which are quick and easy to fix, but it's just kind of frustrating. You have to go through each one and any downstream feature that may have failed. You got to go just like add in the coincident relation. Actually, shouldn't it shouldn't do it. Let's try it. Let's get crazy. Why not? This is like the whole point of this is to like just do it live, right? Do it live. So I think if I make it so the curvature is not so tight right there, kind of loosen it up. Okay. Okay. Come on. It still has that little ripple right there. So yeah, I'd have to play around with. Oh no, you know what? I may have stretched it in both the directions, trying to fix it. Okay, now if I just stretch it in that direction, the ripple is gone, as you can see right there. Okay. But I mean, like clearly, I did it on the other one, and I did it without incident a bunch of times, so it shouldn't be an issue. But I'm running into the issue right now. But you can see on my model, and what I might do is go back and look at like, okay, well this surface might be the one that's affecting it. So like, what's different about this surface? What do I need to change? Maybe start playing around with that as well. So it could actually be, how this surface is related to these two. You have to kind of go back and like, what other surfaces are touching it? That could be what's affecting it. All right, so Yeah, so this somebody asked if this video is going to be available for you to refer back to. I know I did go really fast. I'm really sorry about that. But it'll absolutely it's going to be posted on this YouTube channel. So like in a few days, you'll be able to come back and watch the whole thing, and pause it wherever you want to, and enter all those dimensions. And you'll also have the finished model that you can refer to as well. Which mouse do I use, sir? I use the Logitech Performance MX mouse. It's been around for like, I don't know, like 10 years, and it's just the one I've always used. I think it's like the Cadillac of mice, right? And by that I mean it's big and it's heavy and it turns slowly, but it's such a nice ride. So I'm a big fan of this. You can actually see like how much this one's like worn out right there from my thumb. But I like it a lot. I don't use any of the special buttons or anything. It's just the one I use. I actually have like a backup one. They were like cheap on Amazon one day, so I like bought a backup one, but I still haven't needed to use it because this one's still golden. Okay, create a new plane, convert the sketch entity, and then project the curve onto the new plane. New plane, convert the sketch. Yeah, you can create a new plane and convert the sketch entity, and then project the curve back onto the new plane. You can absolutely do that. Another thing that I could possibly do to fix this, I was just thinking, a lot of times if you end up with a ripple at the bottom, what you can actually do is just say, okay, that ripple right there is no good, but why don't I just trim off that bottom portion that's no good and use a trim surface, slice it off, and then go from there. And that's actually super effective. So that's another way that I could achieve this if that was like if that was ended up being a big problem for me. But I have to imagine that it's actually this surface right here is probably a little bit different than it was in the last few times that I modeled this. Okay. Okay, so I'm going to answer the last two questions. The SolidWorks model is going to be, I don't know, there's a little bit of a lag here, but the SolidWorks model is going to be available right here on this YouTube video. So if you come back to this YouTube video after it gets posted, there will be a link to this model, and you'll be able to download it. It is SolidWorks 2020, so you would need a version of 2020 in order, or no, yes, you would need a version of 2020 in order to open it and use it. But you can always do a dual install. And if you didn't know how to do that, you can contact your VAR. They'll walk you through it. It's not too difficult. And the other one was my PC configuration. I'm using a Lenovo P52. It's got a Quadro P1000 graphics card, which is pretty good, but it's not by any means the best. There's a bunch of models above that, and I have a decent amount of RAM and an okay amount of gigahertz in the old processor, but it's not by any means any like crazy machine. It's a laptop that I walk around with and bang into things with my backpack. It's so you can do crazy stuff like this on a computer that's not a ridiculously expensive computer. Okay. Thanks, Mondo. I like your sarcasm. Big fan. Okay, guys. So the people on the back end have been patiently waiting for an extra 40 minutes at this point. So I am going to hop off, but I really appreciate everybody who's stuck around. Thanks for your time, and definitely, uh, you know, uh, uh, let me know if you made any modifications to the model or you're able to go in and around and play with things. Love to hear about it. So thanks a lot, guys.